Hey guys, it's Mr. Ellis, and by popular request, I'm going to make a quick video about pulleys at the end of a ramp. This is just based on the presentation from class, so here goes. So the idea here, guys, is just use the same strategies you've been using. Just keep in mind that there's an x-axis that bends around the pulley, and so you can treat everything on that line of force, like where the string is, as being on one axis. But there's still other forces, like there's these, normal force, the weight, it has components. One of those components, though, lines up with the x-axis. So that's the one that's going to pull the system to the left, this m1g sine theta, and then this m2g is going to pull the system to the right. So when you look at the entire system, those are those two forces I just mentioned. They work in opposite directions, use the entire system's mass, and you can find the acceleration. So in this problem, you had to use the two masses and figure out what direction it went, and that would influence then how you set up the tension equations when you looked at one object to find the tension. So when you looked at the two object system, this is what I skipped through really quickly just now, was same thing, that you just need to subtract the two forces external to the system that act along the x-axis, act along the line of force, and divide by the total mass. And so you get a negative number. So that tells you it's going to the left, because you made m2g like positive, that's to the right, in terms of the pulley system. So negative means the thing's going to the left. So that means, ignore that friction vector, that means that if you look at m2, the acceleration is up, so the tension is up. So that's why t is positive and m2g is being subtracted from it. And when you do the math, you get 56 newtons. When you add friction, it's just an extra vector. There it is. And it goes, in this case, to the right, because the 10 kilogram block is trying to go downhill. It just opposes the motion. So it could go to the left if the 10 kilogram block is trying to go uphill. In this case, 10 kilograms going downhill. So it's positive, as you can see right here. It's going to the right, the friction. So we add it, and it's the normal force times the coefficient. And to find the acceleration, again, you're looking at the entire system's mass, so it's, m1 plus m2. All right? And that's how you would have done the challenge. Just remember that if there's kinetic friction, UKN, n's always m1g cosine theta, or the mass on the ramp. That's how you're going to find it. If we want to look at this one, the only thing that's different is you get a positive answer, which means it's going to the right. So it's the 10 kilogram block is falling and the 5 kilogram block is being dragged uphill. You could look at the 5 kilogram block if you wanted, but the hanging one's usually easier. In this case, the tension is negative because the thing's accelerating. The 10 kilogram block is accelerating down, so the tension is up. So it's the opposite direction is the acceleration. And then, if the 5 kilogram block is being dragged uphill, the friction is downhill, so now it's negative instead of positive. And you can see the result. All right, so I just wanted to show you a quick solution to those two, and hope that helps you guys study. So I'll see you guys tomorrow when it's time for the tests.